Okay, guys, so we already went through the syllabus. We already got to know each other. So let's start with the class. Let's start seeing the material. So, so let's shift here. So we're here for the class Civil Engineering Systems. Civil Engineering Systems is actually an interesting name because this class, when they taught me this class, it was called Operations Research. And that's how I saw it. And Operations Research is a course that once you take the first course, you start seeing things in a very different way. It's like taking, for example, game theory. Once you take game theory, everything looks like a game. Politics, business, traffic. They even have Battle of the Sexes, so it's interesting. It's interesting how it changes your mind. So I recommended you a textbook, and the name of the textbook is like that. It's Civil Engineering Systems. The author of the book thought that once you apply operations research to civil engineering, you start seeing things as systems. That's the way he saw it. Well, in my case, when I took my first course, I thought I started seeing everything as a linear program. Linear program or linear programming is one of the tools that I'm going to teach in this class. And after I took my first course, everything was a linear program. For me, design, operations, management, planning, even entrepreneurship. So before I continue talking to you about what are the history and what is operations research, actually I'm going to show you a video at the end. But before we do that, let's start with a simple example to see what we're talking about here. Okay, so let's see. So as I told you, when I saw operations research, I started thinking about starting, I don't know, about entrepreneurship. So who of you guys would like to start your own company? Raise your hands. Okay, great. And how do you start a company? Give me some ideas. How do you start a company?
Money.
Good point. Yeah, but here, let's assume that we have the money. Here at the University of Maryland, we have this business plan competition, and you go there and submit a business idea, and you'll get the money. As long as the idea is good, you'll get the money. So let's say money is covered. So what else do we need to start a company?
A team.
A team, good. Yeah, a team. Yeah, I agree. What else?
A great idea.
Great idea. Yeah, great. So let's start looking at some of the ideas out there. So let's start with Bill Gates. So what was his idea?
Windows.
Windows. Okay, great. Let's shift to Larry Page and Sergey Brin. Actually, Sergey Brin came from this university, if you didn't know. What was their idea?
Search the internet.
Okay, search. Okay. Now, what does Windows and Google and searching have in common? Okay, don't say computers, I know that, but what else?
Retrieving information and plain and retrieving information.
Okay, yeah, but something general. What?
Operation.
Operation. Okay, but how about if I want to find what's the cheapest ticket to New York? What if I go to the street and find it myself? Why should I use Google if I can do it myself? I mean, I can go and start asking people around. So what is Google giving me? Or maybe Windows?
Like one-stop shop for everything.
Yeah, well, we're saving time, right? We're saving time. So if you ever want to save time, save money, increase profit, operations research is going to help you. So operations research is not, I'm not giving you a Windows, I'm not giving you Google. I'm giving you operations research. And it's going to open your mind on, once you see an opportunity, this is going to help you see opportunities. So let's start with a simple example. So I want you guys to pick, let's start with one of those companies that, traditional companies in civil engineering. So what do you want to start with? A Windows manufacturer or a furniture company?
Okay.
Pick any
Furniture company.
furniture company. Okay. So furniture company. So I'm going to give you simple problem statement. So here we have. So this is a story. So let's say you go to this furniture company and you're going to talk to the CEO and you're going to tell him that you can save him money. So let's be a little bit more specific and I want you to be a little bit patient. We're going to start with a small idea, but it's going to help you for your big ideas. So we have here a furniture factory. Well, I'm going to display it here, maybe for your convenience. Let's put it here on. So you were contracted by a furniture factory to maximize its profit. This furniture factory specializes in dormitory furniture, making its product of substantial weight and very durable. It makes only student desks, desk chairs, dressers, and tables that are used in lounge space. The factory uses maple for exterior surfaces where resistance to direct impact is important, and pine for interior applications. So now let's see what you found. Let's look at the data. So in this company, limited amounts of maple and pine are available each month to the factory. 2,000 board feet of maple per month and 4,000 board feet of pine per month. And different amounts of maple and pine are required in each of the 4 pieces of furniture. The following table presents these amounts. So for example, if you want to make a desk, you're going to use 7 board feet of pine and 15 board feet of maple, and the same with any of the other products. Now, each type of wood has a different cost: $2 per board foot of pine and $4 per board foot of maple. Each piece of furniture can be sold for a different price: $150 per desk, $100 per desk chair, $250 per dresser, and $170 per table. So, what items should the factory produce each month and what quantities to maximize its profit? So, in operations research, there's always the first step. The first step is to define the decision variables. So let's see. We have the decision variables. Decision variables. This is our only unknown variables. So what are we deciding here? What is it that we need to make a decision on? So any ideas? So
Number of desks to be made.
yeah, correct. So one of them would be like, how many desks are we going to make? So we're going to call that X1. So this would be our number of desks. Then for X2, our number of chairs. Yeah, we're just following the order that we have there. For X3 would be the number of dressers, and X4 number of tables. The rest, we know it. The rest is given in the problem. So, once you define the decision variables, then you only have to think about 2 other steps. So first is we need to define an objective. So here, the problem is we want to maximize profit. Okay? So let's calculate profit. So let's see what is the profit. So we have maximize. So the profit, let's put it here. Actually, maybe we should move. So the profit should be what we get, the money that we get, but it has to be a combination of these decision variables that we already have. So before we continue, we still need to put some guys here, some numbers here. Before we continue, let me check something with you guys. So what is profit? Tell me, what is profit? Okay, we're here to make money, so what is profit, guys?
Revenue minus expense.
Revenue minus expenses, or revenue minus cost. It's so important that I'm going to write it down here. So it's profit equals revenue minus cost. So we need to first calculate the revenues, and then we need to subtract the costs. Here we're going to subtract the cost. Now this is, well, okay, let's figure out some of the values. So what's the revenue if we sell one desk? So 150, right? 150 would be what you get if you sell one desk. And if you sell one chair, how much would you get?
100.
100, okay.
250.
250 and 170, okay. Now for the cost, we need to look at the table. So how much does it cost to produce one chair? We don't have it here, right?
So
For the material?
16. 3 plus 16, 19.
Yeah, you're right. It's simply, you put here the cost of each of the materials. For example, 2 for the pine, plus 4 for the maple, and you multiply each one by how many boards we're going to use. But this is very simple math, and I'm assuming that you're the experts of calculating profits. So let's jump that step. You can verify it later. If you do these easy addition, addition and multiplication, this is going to be your objective. That's the profit that you want to maximize. And now something that is really you're going to find always in operations research is we cannot produce as many chairs, as many desks as we want because there are limitations. And that's when operations research becomes strong, when you have constraints. So what are the limitations here? Why can't we just tell the CEO produce 5,000 desks, 3,000 chairs? I mean, look, for every chair that you produce, it's profitable, you know? You can put as many chairs as you want. So why can't we just make them produce all those chairs and all those tables?
Limited resources.
Limited resources. So the limited resources that we have here is, we see in the second paragraph, we say that there's limited amount of maple and pine. So we're going to look at that. So when you have constraints, you write subject to, because you want to maximize the profit, subject to the following constraints. So we know that there's a limitation of pine, which is 2,000 board feet, and of maple. Okay? So whatever we use of maple or of pine cannot exceed 2,000. Okay? So so whatever we write here has to be in terms of our decision variables. These are numbers, but we need to include the decision variables in some way. So can you guys come up with some simple expression that says how much pine you're going to use based on what you pick as your products that you want to use. Well, this, yeah.
7x1.
Okay, let's see. So yeah, so if you want to produce one chair, you're going to use 7 board feet, and this amount cannot be greater than 2,000. But if you're also producing chairs, so the chair is going to use 1.5 x2, and then the dressers are going to use 10 board feet, and like that. For the same, you would do it for yeah.
So we are assuming here that all the xi's are integers, right?
No, we are not assuming that.
So what does it mean to produce 0.5 desk?
Yeah, good point. Well, for the moment, we're not going to put that restriction. We're going to use, we can, in this case, it's okay to have numbers that are not integer because we're calculating the production for a month. But if you extend this for a year, maybe those non-integer numbers are going to become integer. For the moment, let's leave it like that. So how are we doing in time? Okay. So if you're going to produce, if you're going to focus on the maple, so what would be the numbers that we need to plug here? So I'm going to help you out, guys. 15. Then the next would be, okay, 4, 22, and 10. Okay? Well, so we write. So you can see it there. It's easy. We just need to get the skill to make these formulations. This is the most important thing. One last thing is that somebody can come to you and say, how about if we produce, okay, you're telling me that I should respect this. This is my constraint. How about if I produce 100 chairs, but because that would violate this constraint, so I'm going to produce minus 6 chairs. I mean, I'm going to produce 100, what do you have here? Desks, and minus 200 chairs. So it doesn't make sense, right? It doesn't make sense. So that's why we're going to need an additional constraint. So we need to make sure that all these variables are going to be positive. So once you have the formulation, then the rest, I'm not going to say it's easy, but there are already a lot of tools out there from operations research. So this is a linear program, and its name came because the first problems were made for planning. So they equated programming with planning, but this is not computer programming. So this is the only class where you're going to hear that programming means another thing than coding and computer programming. And this problem is very versatile, and a lot of problems are going to look like this one. Okay. So yeah. So I'm leaving you for homework. Very similar problems. So I want you to look at it, and believe me, you're going to enjoy it because this is going to give you exposure to other problems. So yeah, and here's another problem about a concrete production company. Okay. So that's the end of this section, and now I'm going to show you the video.